Okay, good morning. So let us do the homework, the problems of homework number 4. So let us read the first question. So let x, y, and z be integers such that x minus 2, y minus 3, and z minus 5 are all divisible by a natural number n. The remainder of this combination x, y, z minus 29 by n is equal to what number? We're supposed to put it here. Okay, so what should I do? Because this is the homework on modular arithmetic, I want you to use the idea of modular arithmetic here. So when you say x minus 2 is divisible by n, what can I conclude from here in the language of modular arithmetic? It means that this number, whatever it is congruent to which number module n? If it is divisible, yes? What should I write in front? X minus 2 is divisible by n. It means x minus 2 is congruent to which number module n? Yes? 2. That's the meaning of divisibility. So the same is true for this one. So y minus 3 is divisible by n. Exactly. I can conclude what? Y minus 3 is congruent to 0 module n. And the same for the next one. This is divisible by n. So this means what? It means z minus 5 is congruent to 0 module n. Okay? This is the translation of those English sentences into mathematical symbols. But then what is wanted? So I want you to think. What is wanted? I want to find the remainder of this by n. So what should I do? I need to find which number is that. So this combination is congruent to that number in the module n. So in other words, if you go to a scratch paper, this is your question. And of course, you know that the question mark should be 0 up to at most n minus 1. Otherwise, it cannot be considered as a remainder. But for the time being, that's just a minor problem. My point is that using these assumptions, so you see they are not, it was given like this in an English sentence. I translated those English sentences into mathematical symbols. And then I translated this wanted, the question mark, in a mathematical way. And then I have to answer that question mark. So now it becomes more clear what to do. I want to somehow start with these assumptions and conclude something about this. So what should I do? Because I want to have the combination of x times y times z, it motivates me to start multiplying them side by side, which is possible. Because I told you when I was teaching you, if two numbers are congruent and two other numbers are congruent to the same module, then I can multiply them, add them, subtract them side by side. But if you just naively multiply the left-hand side, it becomes like this. These are loud thinking that I'm sharing with you, okay? So if I multiply them like this, of course, one of the terms will be x, y, and z, which I want, but then I will get a lot of cross terms, which I don't want. Yes, because x will be multiplied by 3, for example, 2 will be multiplied by z. There will be a lot of combinations appearing that I don't need. So even though it is logical to think about multiplication, but multiplication in that way probably is not a good idea. Okay, so that's why I don't continue. It comes to my mind, but I leave it because probably it is not promising that much. Okay, what can I do else if this is not a good idea? What can I do? I want to have x times y times z in a better way. So it doesn't, I don't think if you think in that way, it's not hard to see that. You remember, if I have a congruency, I am allowed to add any number that I like to both sides. So I add 2 to the left and to the right. If I add 2 to the left, it becomes x. If I add 2 to the right, it becomes 2. So from here, I can immediately conclude that one as well. Yes? Or in other words, like equalities, you can move this from one side to the other side, then you make negative, positive, positive, negative. Yes? Okay, and then what happens here? Y becomes congruent to 3 module n. And then this, the same story, z becomes what? Congruent to 5 module n. So what I did, I added 2 units to both sides, which was one of the theorems we talked about last time. But you don't need to do it like that. You can treat that as an equality. You can move things around. And then if it is negative, you make it positive. If it's positive, you make it negative. But then, because I want to have this combination, it motivates me to multiply them side by side. So then what happens, this becomes x, y, z is congruent to 2 times 3 times 5, which is 30. Yes? But which combination I am interested in? I am interested into x, y, z minus 29. So it motivates me to subtract 29 from both sides, yes? And this becomes 1. And that is the answer that we are looking for. Because I told you that when you have congruency, this n module starts from at least 2. Okay, so this is guaranteed that this number 1 is definitely positive and of course less than n. So it can be called the remainder of this one by n. So the answer to this problem is just simply 1. So you see that it will actually help us to do things very efficiently if we follow the arithmetic, this modular arithmetic. Of course, you could use the visibility theorems, but it is not as effective as this method. So the answer that we have to put there in this box is just equal to 1. Any questions here? Okay. So now let us go to question number 2. So let n, so this is probably wrong. Let n be an arbitrary natural number. Consider the following number. Okay, 5 to the 9n plus 1 minus 7 times 2 to the power of 10n plus 3. What can be said regarding the remainder of a by 31? Of course, you have a lot of options here. It is equal to 1 for all n. It depends on the value of n. It is equal to 3 for all n. It is equal to 7, and etc., etc. Okay, but the point is that I want to find the remainder of this number by 31, and n is unknown, but is a natural number. Okay, so let us go to the board now. Again, this is immediately clear that my question is to answer, my goal is to answer this question. I want to simplify this. This is important. By reading the question, you need to understand that I have to simplify this given number in which module? Module 31. So this is my goal. This is the way that you have to think. So I have to simplify the given number in module 31. And of course, do you remember what I told you before? So the numbers that have some powers, so you can go to a scratch paper and try to write the multiples of 31 on the left and the right column. 31, 62, I don't know, 93, and etc., etc. Let us concentrate for 5 now, and then write powers of 5 here. Okay, so 5 to power 1 is just 5, 5 to power 2 is 25, 5 to power 3 is 125, 5 to power 4, I don't know, is 625, as much as you can. Don't go that much further, because by experience I know that these are at the level of your course. It shouldn't be hard to find them. But what was the ideal scenario? I called it the ideal scenario, yes? Do you remember? So the ideal case is that one of these numbers is either exactly equal to one of these numbers or differed by it by 1 unit. If I can't find a scenario like this, then I am in a good shape. But of course, could you see it in the way that I have written it? It is not very clear, but the next one is what? The next one is 124. So that's why I'm saying that if you stop too early, might be you don't see it. But then let's continue. And then immediately you see this is the ideal scenario. Yeah, so it was not that hard, by the way. Without calculator, this level of calculation should be doable for you. Okay? So now that I have this, the ideal case, I understand that I have to start my calculation based on the third power of 5. Okay? So remember this. But let me do another one for 2. 2 is also simple, yes? The list, so let me stop this list here because we discovered that. But this list is the same, but now this time I write powers of 2. 2 to power 1 is 2, 2 to power 2 is 4, 2 to power 3 is what? 8, 2 to power 4, 16, 2 power 5 is what? 32. And then again, you get your ideal case. Yes? Because now the fifth power of 2 is 32, and it differs by multiple of 31, which is the first one, just by 1 unit. So it also motivates me which power I have to start with for 2 to that power, 2 to power 5. So if you made this discovery, which was not hard, then you know what to do. Okay, so what I do, I will continue like this. I realize that I have to start with a power of 3 for 5. But that is not hard. This is a Math 1C problem. I want to write this in a way that 5 to power 3 appears. So what should I do? Instead of 5 to power 9n plus 1, I hope that you immediately understand that I can write it as 5 to the power of 3 and then to the power of 3n, because so far I have 5 to power 9n, but I have one extra 5, so I have to multiply it. So instead of this expression, I wrote it like this. And then I copy and paste -7, but I understood that the base of my calculation should be the fifth power of 2. So I have to write this in a way that fifth power of 2 appears. So, and that is also easy. So I write 5, 2 to power 5, but I need to go backward to reach to 10. I need to go forward to reach to 10n plus 3. So what should I write here? 2n, because so far I have 10n, but I have 2 to power 3 more. Yes? So this is this observation you make, and after that observation, it is not hard to write this in that form. Okay, but as we learned last time, 5 to power 3 has a different name, has a very good name in 31, the ideal case. So what can I write instead of 5 to power 3? 5 to power 3 is 125. Can I write it as 1? 125 is congruent to 1 module 31. Why? Why? Yes? Okay. Yes, yes? Yes, because this number, the number on the left minus the number on the right is 124. 124 is divisible by 31 because that's a multiple of 31. Yes? So, instead of 5 to power 3, what can I write simply? I can write 1 to power 3n multiplied by 5 minus 7. What can I write instead of 2 to power 5? 2 to power 5 is 32. I can write 1 again because 32 minus 1 is 31 and 31 is divisible by 31. So again, I write 1 here. But to the power of 2n minus 2 to power 3 is a small number, so not minus, sorry, multiplied by 2 to the power of 3, which is 8. And then I can simplify this. So it was not a hard problem. So you see, 1 to power 3n, independent of what n is, it is always 1. And this one is also 1. So I am left with 5 minus 7 times 8. What is 7 times 8? 56. So these are small numbers. And 5 minus 56 is what? Minus 50, 1 module 30. So I was able to simplify this expression, this number, in module 31, and I got minus 51. But minus 51 is not acceptable as the remainder, yes? Because the remainder should be a non-negative number smaller than 31. But minus 51 is actually a negative number. So what should I write? I need to write a number which is on the one hand congruent to minus 51 module 31. On the other hand, it is both positive and smaller than 31. What that number is? What should I write? Yes? 11. Why is that? Is minus 51 congruent to 11 module 31? Yes, because the number on the left minus the number on the right is minus 62, and minus 62 is divisible by 31. So that is correct. So 11 is correct. On the other hand, is 11 positive? Yes. Is 11 smaller than 31? Yes. So this is acceptable as the remainder. So the answer to this problem is always 11, independent of what I choose for n. So which answer is that? This one. Yes? It is equal to 11 for all n, without knowing what n is. Yes? Is that clear? Okay, so now let us go to the last question. Consider the following very, very huge number. The remainder of a by 12. We want to find the remainder of this number by 12. So these kind of calculations, so don't fall into the trap that this number is horrible, yes? These calculations usually are very simple, especially at the level of your course. So how can I do that? I want to find the remainder of a by 12. So what I expect you to immediately understand is that they are asking you to simplify a in module 12. But they have expressed it in this format. So what you need to do, you need to write 241 to the power of 2025 plus 242 to the power of 2025, and then the next one to 43 to the power of 2025, and this list continues until 251 to the power of 2025. And my goal is to simplify this number module 12. Okay, that's it. But I told you that if you have a number which is above the module, it is always better to reduce the number in that module, make it smaller, okay? Because, for example, can you tell me immediately this number? I don't think you have a problem. So 241, forget about the power. You can always do this for the bases, not exponents. For the exponents, you have to use some trick like that. But here, the problem is still not the exponent. The problem is with the base, because base is much bigger than my module that I am working. So the first question comes to me is not worrying about the power, I'm worrying about the base, because the base is extremely high, okay? So, but how should I get rid of it? I need to ask myself, what is a name, what is a better name for 241 when it comes to power, when it comes to module 12? What is that? Yes? It's 1. Why? Because 241 is congruent to 1, module 12. It shouldn't be very hard for you to see. Of course, in the beginning, you might be slow, but it is coming if you practice. So is that correct? Yes, because this number on the left minus the number on the right is 240, and 240 is divisible by 12. So 241 is nothing except 1. So it means that instead of this one, I can simply write 1. Okay, but the next one becomes very clear now. Yes, what can I write for this one? What? I can write 2, yes. Why is that? Again, 242 minus 2 is 240, and 240 is divisible by 12. Okay? So then, of course, it becomes clear. Yes, what is the next one? 243. What is the next one? 3. Yes? So it becomes 3 to the power of 2025, and this will continue this list. Can you tell me finally what is the last one? 11. Yes, because 251 minus 11 is again 240, and 240 is divisible by. So if you continue this list, it goes up to 11. Okay, there is only one twist to the problem. By the way, if this is given in the exam, if you have written this one, of course you get some points. So that's why I'm saying that don't give up. This one is super easy because 1 to this power is just 1. But the problem remains for the rest of them. And if you really want to do the same trick for each one of them, the exam time will be finished. Yes, because you want to do it once, that idea for this one, that idea, by the way, it is not very clear that we can find the ideal scenario in one of them, so it becomes horrible. Okay? So this is why you have to change your strategy, because the old strategy, even though in principle possible, but definitely it's extremely time consuming and demanding. Okay, so how do you think now? Okay, so that's the only thing. Of course, up to here, you shouldn't be that creative. I'm just following the recipe. But here is the first time that I have to think. Because, why should I think? Because the idea that we developed before works, but in principle, not in practice. It's too lengthy. Okay, what can I do now? Okay? Do you see the trick? For example, let me give you a hint. So what is the number before this? When I reach to 11, what is the previous one? What is the previous one? Is 10. Okay. My guide for you is to think this and this together instead of thinking about them separately. Okay, do you see what happens now? What is another name for 11 in Module 12? 11 is quite good, because 11, first of all, is not that big. On the other hand, is smaller than 12, so it is good. But what is another name for it, which is very suitable here, if I insist to consider them together? Yes? Minus 1. Do you see that? 11, of course, is good, but you need to be quick in this kind of thinking. Yes, 11 also can be written as minus 1 module 12. First of all, why is it true? Because the number on the left minus the number on the right. 11 minus 1 is 12, and 12 is divisible by 12. So another name for 11 is minus 1, but I hope that you understand that this name for this problem is better. Yes, do you see that? Because I can continue. I can write 1 to the power of 2025. So if you don't mind, let me do them case by case, because I hope that you know the trick now. So I will group them together. Okay. And then what do you think what I'm going to do? I think it's clear. Yes, I would write 2 to the power of 2025. I will group it with with the one to the last, which is this one. Yes. But how many terms are there? 11. One of them will be left alone. Yes. So if I group them in this way, what is the next grouping? Is 3 to the power of 2025 plus what? 9 to the power of 2025. Okay, so if you don't mind, let me write everything so that you are not confused. So it is 4 to the power of this plus the next one is what? 8 to the power of 2025. And the next one is 5 to the power of 2025 plus 6 to the power of 2025. Yes? So which one is left alone? Is there anyone left alone? Because here I have 1 up to 11. There are 11 numbers, so the number is odd. So one of them is left alone. 1, 2, 3, 4, 5, 6, 7 is left alone. Do you agree? Yes? Do you agree with that? Yes?
What did you switch out? 6 for 7. Is there a specific reason?
No. Might be I am confused. No, this is 7. Yes, you are right. This is 7. So which one is left? Thank you for fixing this. So 1 and 11, 2 and 10, 3 and 9, 4 and 8, 5 and 7. But one of them is left alone. Yes, which one is that? 6. Do you agree? Okay. But now, what is another name for 11? Is minus 1. Can you tell me what is another name for 10? Is minus 2. Yes? Is that understandable? 10 minus minus 2 is 12. 12 is divisible by 12. What is another name for 9? Is minus 3. What is another name for 8? It's minus 4. And what's another name for 7? Is minus 5. Yes? Understandable? But do you see this is good? Because 2025 is an odd number. So 1 to power 2025 is opposite to minus 1 to power 2025. So these two numbers are gone. Yes? And the same story here. 2 to the power of 2025, I don't know the number. But minus 2 to the power of 2025 becomes opposite of this number because 2025 is odd. So if this problem was, if I have given you 2026, it was not that easy to calculate. So calculating for odd ones are simple. And again, minus 3 to this power and this 3 to power, they cancel one another. Yes? So what happens? It becomes what? 31 minus 1 to power 2025, and this one, it is 0. 2 to this number and minus 2 to this number, they are opposite to one another because 2025 is odd. The same is true here, the same is true here, and the same is true here. Yes? So I am left only with what? 6 to the power of 2020. 6 to the power of, so why did I write 31? So, sorry. It is what? 12. It is 12. Okay, so at least I succeeded to simplify this expression in module, so this is also wrong, sorry. You have to fix me when you see a mistake, please fix me, okay? I don't know why you hesitate to talk. Anyway, so then it becomes 12. So I have to continue because it is not finished yet. So what do you think I will do now? I have to just simplify this one. Yes? But what is this? So you see, instead of having 11 terms, I have only one term to deal with. Okay? So then in principle, the previous method should work. But that's also very simple, isn't it? Because 6 to power 2 is 36, and 36 is divisible by 12. Yes? So it means that I can break it as 6 to power 2, and then to the power of what? 1012. So far I have 2024, but I have 2025, so I have to multiply by an extra 6. Yes? But why it is beneficial? Because if I ask you what is a very good name for 6 to power 2 when it comes to module 12, what is the answer? 0. Why? Because 6 to power 2 is 36. 36 is divisible by 12. When a number is divisible by a number, in that module, the name of this number is just simply 0. And then 0 to any power multiplied by 6 becomes 0 again. Yes? Okay, so this means that the remainder of this number by 12 is 0. So we have to write 0 here, either with numbers. I mean, writing it numerically for autocorrection is much better. Any questions? No? Okay, thank you.